When we're describing in words the transformations of any graph, whether it be absolute value or a different type of function, we're going to use the words that we took in our notes at the top of this page. So words like reflection, shift, stretch, compression, vertical, horizontal, those types of words. Remember that when we see the original function, f of x equals the absolute value of x, that's our parent function. And any transformation of that, when I take a look over here at this f of x minus 2 plus 7, we can replace the f parentheses with those absolute values because that was our parent function. So let's recall that the inside value gave us the horizontal shift. We went either left or right, and that one takes the opposite sign. So instead of going in a negative direction, we're going to go in a positive x direction, which is to the right. So we have a horizontal shift to the right 2 units. And similarly, when we have that value outside, being added or subtracted outside of the absolute value bars, outside of our function, that's our vertical, our up and down shift. And those are not as high maintenance, those are going to stay as is, so that plus 7 tells us to go up 7 units. It's a vertical transformation, so we're going to say it was a vertical, meaning up or down shift, that was up because it was positive 7 units. And those are the only two values that we see, and so they're the only two that we have to mark our that we have to describe the transformations for. Similarly, when you are given a function with transformations, the transformations are described for you and you're asked to write a function, you're going to take those words and turn them into an equation. So again, we're starting with our parent function, the absolute value of x. We're going to write a transformed function g of x. So the name of our function is g of x equals. So remember that we have 4 separate options for transformations. The first that we talked about was the horizontal left or right shift. The second we talked about was our vertical up and down shift. And then finally we talked about the a value, the number being multiplied, the coefficient of our function, which can issue either a reflection and or a vertical stretch or compression. Okay, so what we're looking for here, we've got a vertical translation 4 units down is the first transformation that's described, a vertical translation 4 units down. And when I look back at my notes, I see that my up and down vertical translation, that matches my outside number that gets added or subtracted. It's down 4 units. Since it's that vertical translation, non-high maintenance, we're going to go with that minus 4. And then the horizontal translation of 2 units to the left, that was my inside number that gets added or subtracted to the variable. Now, since it went to the left, which is in a negative direction, and you can see it in your notes, what happens is that ends up being a positive value. So 2 units to the left gives me a plus 2. Remember, I should have put it there in the beginning, but the x is there inside the absolute values as well. There's no number in front because there's no reflection and there's no vertical stretch or compression. So if I were to rewrite this without the highlights and everything else going on, we would say that we have the absolute value of x plus 2, all minus 4. And then the last thing that we're going to be asked to do is again describe a transformation given the functions here, which are very similar to exactly what we did for numbers 11, 12, and 13. So again, we're looking at those functions and we're deciding what's happening with our functions. What are the transformations? So again, remember what's happening with your function. Use those colors if they'll help. All right, and again, the parent function that we're looking at is the absolute value of x, but keep in mind that whether it says absolute value of x or x squared or the square root of x, it doesn't really matter what the parent function is. The f parentheses will apply to any parent function that we want. And then the one last possible transformation was that outside number, which we don't have. So there's actually no vertical shift up or down. What I want to do is start from left to right. I'm going to read this just like a sentence. So the transformation performed on f of x to get g of x equals negative. Remember, the negative is its own transformation all in and of itself, and that's our reflection. Please make sure that we specify that it's over the x-axis. We can reflect over pretty much any mirror, any axis or line that we want to, so it's very important that we specify that it's a reflection over the x-axis. And then that 1/4 tells us that we have a vertical compression. Please recall the difference between a vertical stretch and a vertical compression. A vertical compression, because that number 1/4 is less than 1. It's between the 0 and the 1. So if I looked at the decimal equivalent of 1/4, it would be 0 point something. In this case, 0.25. So a vertical compression. And then finally, the +1 inside the parentheses, which would go inside our absolute value bars, tell me to go in the opposite, so a negative x direction, which is to the left. So we have a vertical shift. I'm sorry, it's horizontal. It's an x direction. Let's change that. A horizontal shift. So it's to the left 1 unit, because left is that negative x direction. That +1 tells me negative direction for my x values. So your task is to complete the rest of the exercises here, 12, 13, 15, 16, 17, 18, 19, 20, and 21. Resubmit the assignment when you're done. Have a great day.